Hey guys, welcome back. Houston Math Prep here. In this video, we're going to look at putting together all of the skills that we've been working on in our polynomial graphing series, putting all those together to graph a polynomial from factored form. If you haven't seen our previous videos on end behavior, turning points, roots, and their behavior, make sure you go back in the playlist and check those out first, and come back here to join us when you're ready. Okay, so we're going to graph this h of x polynomial. I'm going to gather some information along the side here, the degree, the lead coefficient, the end behavior, and all of the roots with their behavior, and then show you how to put all that together on a graph. So the first thing that we want to find out is our degree. Now typically we easily find our degree from the highest power of x in standard form, but here our polynomial is given to us in factored form. So in factored form, the way that we find the degree is we add up all the exponents from each of the factors. So here with x, since I don't see an exponent, I know that that's a 1. For the factor of x plus 4, once again, I didn't see an exponent, so I know that that is 1. And for our factor of x minus 3, I have an exponent of 2. So 1 plus 2 tells me my overall degree is 4. For my lead coefficient, again, we're very used to looking at the highest power of x term and just taking our coefficient from there. But since we don't have our polynomial in standard form, we can just look at the product of all the coefficients of x. So here I have 1x. Here I also have 1x. And here I also have 1x. So 1 times 1 times 1 gives me a positive 1 as my lead coefficient. So putting those two pieces of information together, that tells me with a positive lead coefficient, I know that my right-hand end behavior is up. With an even degree, the other piece of end behavior should be exactly the same. So on the left, I also have up. Gathering each piece of my root with my behavior, taking each factor and setting it equal to 0, I first get a root at 0, 0 from my x. It has a multiplicity of 1, which is our highest power there. So I know that that one is going to cross through the x-axis. Odd multiplicity crosses. Taking my second factor of x plus 4 and setting that equal to 0, I get a root of -4, 0. Looking to the exponent for multiplicity, I once again have a multiplicity of 1. Odd multiplicity also means cross. And for our final factor, setting x minus 3 equal to 0, I get a root of 3, 0, and a multiplicity of 2, since it is raised to the 2 power. And I know that even multiplicity is going to give me touch behavior at that root. Okay. So once I have all this information gathered, it's time to put that on a graph. The first thing that I want to graph is I'm going to graph each one of my roots. So I'm just going to go ahead and put a dot on the x-axis at those locations. So first I have a root at 0, 0. I also have a root at -4, 0. And my last root that I found was at 3, 0. So go ahead and graph each one of your roots onto your graph. The next thing that I want to add is my end behavior. So going to the farthest left root, in this case -4, I know that out of that I need to go up. So I'm just going to go ahead and kind of in a curved way add up end behavior out of that root. And then I'm going to do the same thing on the right. Go to the farthest right root and graph that end behavior of up. The last thing that I want to do is use each root's individual behavior to know how it should behave. So going from left to right, at -4, I said that the graph needs to cross through at that root. So I'm coming from above, I need to cross through and come down. Now to get to my next root at 0, I'm going to have a turning point. The only way to get back up here to cross through at 0 is to turn around. So I'm going to follow that behavior and turn around. At 0, 0, I'm also supposed to cross through. So I'm going to go ahead and continue that motion to cross through at 0. And then again, thinking logically here, the only way to get back over to 3 is to have another turning point. So I'm going to have to turn around. And that should finish up my graph, but let's just make sure that it does jive with what we said. At 3, we're supposed to have the touch and bounce behavior, and we do see that happening. At 3, we are touching the axis and bouncing back up. So here's a rough sketch of our polynomial for h of x equals x times x plus 4 times x minus 3 squared. All right, guys, that does it for this example video. We'll catch you in a future one.